class. This is just a quick little discussion about linked lists, which will be our next topic. Uh, so far, we've covered stacks and queues, which are data structures that hold some things and they have certain rules that apply to them. Arrays, which you can just put whatever numbers or whatever things in you want. If you want them sorted, we have sorting algorithms for that. Now, if we want to insert anything into an array and it has to be in order, you know, it's kind of a tedious process. If the array is full, well, you have to make a new array and move everything over. If the array's not full, and you want to keep everything in order, you're going to have to move a bunch of numbers around. So it's actually a lot more difficult to keep things ordered with an array. A linked list is a data structure that kind of makes it so we don't have to worry about that as much. Essentially, it's significantly faster, deleting and inserting things. Probably about the same as, if we're finding things as an array, but insertion deletion is much, much faster. So let's talk about what a linked list is. Now, a linked list essentially exists, there we go, as nodes. And usually the nodes are kind of denoted as little squares. Now, inside these nodes, you can put whatever data you want. For our purposes, we're just going to keep it very simple. We're going to, just put in, I don't know, maybe some numbers. Let's say 6. And this node would be, we'll go with 9. And this node would have, let's say, 12. Something like that. Now, we can put anything we want. We're going to use numbers because that's the easiest way to, boil it down and represent things. Now, each node has a number, but it could have whatever we want in it, honestly. Now, there's also another thing it has, which is called a next. It's a pointer that points to the next item in the list. When they say linked list, they mean that basically one list connects to the next. This next points to this. This next at the end would point to nothing. Basically, what you'd have at the end of a list is null. Like this. Now, the cool thing about a linked list is if I want to insert something into a list, I don't have to rearrange numbers or do anything. I just have to rearrange these pointers. So this next, if I want to insert, let's say, a 7 or 8 even, I have an 8 I want to insert. 8. Now, numerically, it's going to go between these two, right? Of course, my list is already built. So basically, the first thing I need to do is search my way through this list until I find where it needs to go. Once I find a number that's too big for it, then, well, it needs to go in the previous one. So in order for me to do this, I just simply have to point the pointers. And it is automatically kind of added to this link in between. Now I have to be careful about this. If I point this pointer next down to here, but I don't point anything up to this, then I basically just cut off the entire rest of the list. This pointer has to go first. So in the end, this pointer is going to have to point up to that first. That's the first item. Now, this guy will have to move down. So instead of it pointing there, I would point it down to this one, like that. And then this wouldn't exist anymore. So now as far as my linked list is concerned, this is the order that it's in, just like that. Now if I want to delete something, kind of similar, if I delete the first one, there's several different cases we'll have to discuss, but when we get to that, I have to, remove this, and this is now the first item in the list. This is the last item in the list. We'll get more into the detail on that later. Deleting something in the middle is probably the easiest. The end is the absolute easiest. But there are different things we're going to have to program when we're doing that. Now this right here is what's called a singly linked list. singly, I think it's linked list. Basically, we have one pointer that points to the next item in the list. The other type of list would be a doubly linked list. Instead of having a next, which is what these pointers are, next, next, it's going to have a next and another one. We'll have that next that points to this way, and we'll have a previous that points the opposite way. So one points to the next item, and one points to the previous. So a doubly linked list actually lets us go from one direction to the previous direction, just like this. Of course, that involves a little extra coding. But the benefit for this is if I move down this list and I go too far, I can easily use the previous to jump back one or two. If I'm going on the list with a singly linked list, then it's a lot harder to go back because once I move up, I can't go back anymore. Unless I have two pointers that are pointing to each of these little nodes. Now the third type of linked list would be what's called a circular linked list. And essentially, it's just like your normal linked list. There's that points to the end. You know, points to the next, points to the next. But instead of pointing to null, it's going to point back to the beginning of the list. Basically, it makes a big circle. So I'll try to do this as best as I can. Let's see. There we go. Shoop. Shoop. Like so. So it basically just makes a big circle is what this does. And that would be a circular linked list. Those are the three types we're going to be discussing this coming up chapter. And we'll get more into, and this would be a doubly linked list. All right. It might have a Y either way. Doubly linked list, singular linked list, and circular. Those are the three we're going to code and program. And you guys are going to see them up close and personal. Now, of course, just like with any other programming data structure, there are things like this built into Java, but to understand how they work, we're going to have to obviously code them from scratch. So look forward to that.